So now here we will discuss postulates of quantum mechanics. Okay, postulates. So the number one postulate is called as state of a system. State of system. It is relating to the state of system. Okay, so what do you mean by a state here? State in the sense condition. Okay, so condition. What do you mean by a system? System can be any quantum particle like electron, neutron or anything. Okay, so any microscopic particle about which you wanted to know, okay, is called as system. So how do you find out a state of a system? So where is all information relating to the system? Where is all the information relating to the system? It is there in the form of psi, that is wave function. So what does this postulate says is psi, which is represented as x comma t, or just psi you can call it as. Okay, so psi is a wave function. It is a wave function. Okay, right, and this wave function has information about quantum particle. So what information it has? It has information related to, okay, so it has data related to position. Okay, so from psi value you can come to know the position of an electron, or you can come to know the momentum of an electron, right? You can also come to know the energy of a system, right? Yes, so that is the importance of psi, and psi is very, very complex. This particular psi is very complex. Okay, and also one more point that I would like to mention is, the psi square. Okay, so the square of psi is called as probability density. It is called as probability density. Okay, and this probability density talks about position of a quantum system or position of an electron. Okay, so in chemistry, about what we will like to know? We will like to know about an electron. So directly, instead of calling as a system, you can say it as electron. So this is postulate number one. So this is the first postulate. So what is the first postulate talking about? It is talking about the state of system. Okay, so in Schrödinger equation you have something called wave function, and this wave function has got complete information about position, momentum and energy of a particle, and the psi square, if you square its value, it is a psi square which is called as a probability density, and it will talk about majorly the position of an electron. Okay, so this is postulate number one. Now coming to postulate number two, observables and operators. Okay, so in postulate number two is all about observables and operators. Okay, so what does the quantum mechanics say is the operators, there are something called operators. So you have to tell the definition of operators here. So we have operators. What does the operators tell us? How they are useful? That if you tell, that becomes a second postulate. Okay, so these operators are the mathematical tools. So they are the mathematical tools which I explained in the previous video. Okay, so these are the mathematical tools which actually transforms complex psi values into simple meaningful functions or values. Okay, so using these values, okay, so using these values, okay, one can understand, one can measure and understand about observable, okay, very important, observable physical quantities, like okay, momentum. So these momentum, position, energy and etc. are what we wanted to find them. So if you want a measurable value for these physical observables, then operators will help us. Okay, so all the information relating to these physical quantities are hidden in psi value, but the psi values are very complex, you cannot understand them properly. So we have operators which are nothing but mathematical tools, say they transform these complex psi values into understandable functions. Okay, so understandable digits. Okay, so that is all about the second postulates. Okay, so now moving forward to the third postulate, it is measurement and eigenvalues. So here they talk about eigenvalues and eigenfunctions. So you have to tell the importance of eigenvalues and eigenfunction here. Okay, say suppose a Hamiltonian operator which is operated on a wave function psi, and you will get E psi, whereas this is a measurable digit or meaningful digit, okay, meaningful digit which makes us understand, about the physical quantities like okay, position, momentum, P means momentum, E means energy and etc. Okay, so that is importance of eigenvalues and eigenfunction is what you are talking about in this particular postulate. So the third postulate is called as eigenvalue postulate or eigenfunction postulate. Okay, so now moving on to the fourth postulate, which is also very very important, that is time evolution. Okay, so time evolution and expectation value. Okay, so what do you mean by time evolution? That means the wave function gets evolved over time. Okay, so in time dependent Schrodinger's equation, so previously whatever the equation I gave it the equation which does not dependent on time. Okay, but here in time dependent Schrodinger's equation, you know, the wave function evolves. Evolves here means changes. The wave function changes according to time. Okay, so you have an equation to represent that. So just take this equation. So you have I h cross, okay, into del psi by del t is equal to Hamiltonian operator into psi. Okay, so this is a time dependent Schrodinger equation, where this equation actually tells us the psi value depends on temperature. The psi value keeps on varies with respect to the time. Okay. This equation tells us that the psi value keeps on varies with respect to time here. Here t means time. Okay, so this is all about the different postulates of quantum mechanics. Okay, so in exam you can write all these points something like this only. Okay, so keep the heading and explain the point one by one about the state of a system, about the operators, about the eigenfunctions, and about the time evolution. Okay, so these are the major postulates of quantum mechanics.